Okay, year 12. So what we're going to do today is some revision of solving trig equations and using trig identities. So to start off, this is kind of quite a standard exam type question. So solve in the range 0 to 360 degrees this equation here. So we've got 9 sine and then theta plus 60 equals 4. Now the first thing we want to do is to rearrange that so we get sine theta plus 60. And to get it from this to this, I've divided by 9, so I do 4 divided by 9, like that. Now, what is super important here? We can't subtract 60 from both sides because this plus 60 sort of is part of the function. So what we're going to do instead is we're going to do the inverse of 4 over 9. So we're going to do inverse sine of 4 over 9. And when we do that on my calculator, you get this. You get 26.4 degrees to 1 decimal place. Couple of things though. Point 1, this is not our final solution. Point 2, because we've added 60 here to what's happening to our sine theta is theta plus 60. We're going to add 60 to our range. So rather than looking in the range 0 to 360 degrees, we're actually going to be looking in the range 0 to 420 degrees. Okay, that's the range I'm going to be looking in. Now 26.4 degrees isn't within that range, you can tell that. So we're going to need to find the other values which are within that range. So it will help at this point if you can sketch out your sine curve. So super kind of quickly then, this is approximately what my sine curve looks like, this sort of thing. So it starts at 0, 0. This point is 180. This point is 360. This point would be 540. This point would be 720 and so on. And this here is 1. And this here is minus 1. Now we've got 26.4 degrees. So 26.4 degrees would be about here or so. Okay, because if this is 90, this high point is 90. So let's just say 26.4 is about that. So then there would also be a solution at this point here. Now, because we know this is 180, to work out this value, I would need to do 180 minus 26.4, which is 153.6. So 153.6 degrees we've got. And then just reading across, there'd also be this point here. So if this is 360, this would be 360 plus 26.4, so 360 plus 26.4, which gives 86.4 degrees. And then there would also be this value here. Now this value would be, this point is 540, so it would be 540 minus 26.4. Now 540 minus 26.4 is 513.6. 513.6 is outside my range, so I'm going to ignore it for now. Final thing to do, year 12, and this is why this is worth quite so many marks. This here, these values here are our values for theta, but we've got theta plus 60. So now, if we know that theta plus 60 equals 153.6, to find what theta could be, you'd subtract 60 from both sides. So we get theta equals, let me just do this, I'm going to, would be 93.6. So theta can be 93.6 degrees. The other version we would do is 386.4 minus 60, which is 326.4 degrees. These are our final solutions to the original equation. And this is good because they are both within the original range of 0 to 360, which is what we wanted. Now, at this point, as a quick check, what you could do is you could take your values for what theta could be. So, for example, if we take 93.6, do 93.6 plus 60, then do sine of that, then times that by 9. And you should find, when you do that with your calculator, so all I've done is I've done theta, so 93.6 plus 60, sine of that, times by 9, and I get an answer that's super close to 4. It's not exactly 4 because of like the rounding and so on, but it's super close to 4, which therefore means that these solutions are correct to 1 decimal place. Okay? Okay, year 12. So part 2 of the same exam question, we've got to solve this time in the range 180 to 180, negative 180 to 180 degrees, this equation here. Now this, you can't solve in its current form because we've got tan x and we've got sine x. So we're going to need to do something so that we've not got this variable here. We don't want tan and sine in the same equation to solve it. So we're going to use one of our identities. And one of the identities that you need to know is this: sine x over cos x is tan x. Those two things are identical to each other. We can go back over why that is the case if that would be helpful to any of you, but most of you just need to learn this. So generally, because we've already got sine, it makes sense to get rid of this tan. Like often with these sorts of questions, you'll get like a feel for the best way to approach them. And sometimes you'll like try something and it won't quite work out. But something like that would be a good place to start. So then it's still quite hard to solve because of this form it's currently in. So I could try multiplying by cos x. When you multiply by cos x, we are going to get 2 sine x minus 3 sine x cos x equals 0. So I've just multiplied each term, this term, this term, and this term by cos x to get me that. Okay, so now what? Right, so what you could do now, this has got a sine x in and this term has got a sine x in. When that happens, always good to try and factorise and see if that helps you to spot anything. So when we factorise, we are going to get 2 minus 3 cos x equals 0. And now this is solvable, okay? No, blah, blah, ignore that. This is solvable. And the reason this is solvable in the same way that you normally solve a quadratic. So we either get this thing equals 0 or this thing equals 0. So let's go with sine x equals 0. So then to find what x is, we would do inverse sine of 0, like that. When we do that on our calculators, or alternatively just using our knowledge of trig, we get 0. Okay. Now, just before we move on, it's useful to now sketch out our sine curve. So our sine curve looks like this. And then because we're going in the range minus 180 to 180, we'll go back a bit. Oh, wait, ignore that. I can't write there. Let me redraw it here. So this is my positive sine curve, like that-ish. And then my negative, like that-ish. So we've got the solution 0, which is perfect. But then we're also going to have this value here, which is negative 180 degrees. We're not going to have this value here of positive 180, because if we refer back to our original range in the question, it can be equal to negative 180, it can't be equal to 180. So those are the values for that part. But then we also get 2 minus 3 cos x equals 0, in which case we get 2 equals 3 cos x. So to find cos x, we would divide by 3, giving 2/3 equals cos x, like that. So then to find x, you're going to do inverse cos 2/3, which gives on your calculator 48.19 degrees to 2 decimal places. And then we need to consult our cos graph to check that we've got all of the required values. So that is a horrible straight line, I'm really sorry as well. Our cos graph starts here, starts at 1, goes down and then goes back up like that. And then similarly here, just like that, what I've done. Okay, so this point here is 360, this point here is 180, this point is 270, this point here is 90. So therefore, our value of 48.19 is going to be about here. Now, bearing in mind we're only working in the range minus 180 to 180, this is the range we're dealing with. Okay, between here and here. So the only other value of cos I need to find is this one. Using the symmetry of the graph, that would be minus 48.19. And then probably, just to write my final answer, I would write all of my values out in order from in ascending order. So I would write them as minus 180 degrees, minus 48.19 degrees, 0 degrees, and 48.19 degrees.